All right, so today we are looking at solving one-step equations, all right, and then we're also looking at some translating that's going to be going on here, okay? So, first thing here is we got to go through some definitions, make sure we understand so that when we talk math, we can talk it, all right? When I say something, y'all know what I'm talking about. This is more so all that is, okay? So, first things first, when I say the word variable, okay? A variable is a letter or a symbol used to represent a value that can change, okay? So when we're looking at these things, typically when we all think of a variable, we think of the letter X. That's right. None of y'all are going to say it, okay? So a variable, it's any kind of letter. So we've seen X, we'll see T, we'll see Y. Those are some of the popular ones that you're going to see. You'll see the letter N, you'll see the letter M. All of those are just a representation of a variable. And again, all that is a value that can change, all right? The next thing you're going to see is a term that we call the constant, all right? And a constant is a value that doesn't change. So just like the warm-up that we looked at, a constant is a number value. For instance, the number 4. Will the number 4 ever be anything different than the number 4? No, it's always going to be that. There's nothing attached to it. It's constant. It will always be the same thing. All right? Now, the next ones that we're going to look at are some words. A numerical expression. Okay? A numerical expression contains only constants and operations. So this is a case where if you look at something and all it is a set of numbers with different operations. So for instance, I'm going to give you an example. An example of this. You could have 2 plus 7 minus 6 divided by 13 times 25. That is an example of a numerical expression. They are all numbers, and then it is just mathematical operations in there, okay? Now, the one that we are going to end up probably focusing on the most is called an algebraic expression. This may contain variables, constants, and operations. An example of this, okay, are a lot of things that you have seen before. It could be 2x plus 9. Okay, what makes it an algebraic expression is simply the fact that it's got this variable right here. All right, everybody okay with that? Okay. All right, moving on. The operations along with the words used to represent them. So as you're looking at this, some things that will really help you out, all right? Whenever you see an addition sign, all right, and this is all written on there, so I'm just going to talk about it. An addition sign, the words that should correlate with it are plus, sum, increased by, all right? Now, everybody knows what a plus sign is. You see it, you automatically pretty much know what to do. The things that are going to be big are these words down here because you're going to be given some things in a written form where you have to translate it into a expression. So you might have something, for instance, a number plus 7. Oh, well, that means it's x plus 7. Okay? And we're going to get there, but that's really what we're doing here. Subtraction, the big words you should think of are minus, difference, or less than. Multiplication, that is times, product, equal groups of. And then division, the last one, divided by or quotient. Okay? The one in division that a lot of students struggle with is quotient. Quotient is just another thing that says the answer of a division problem. That's what a quotient is. Everybody good? Am I going too fast? Good. All right. So let's come here and look. Translating from algebra to words. All right. So right here, you need to give 2 ways to write each algebraic expression in words. So what happens here is they give us an algebraic expression. We need to write it using words, okay? So I'm going to look at letter A here. Letter A says simply what? 9 plus R. Well, guess what the first way I'm going to write it is? 9 plus R. Simple as that, right? Now, these 2 ways that I'm going to give you aren't the only ways, but they're the ways that you're going to see. All right, So 9 plus R. All right. The next way that you could do it. Does anybody have a way? Do you want me to give away? Oh, we're not there yet. We're not. That is correct. We're still on letter A. They asked us to do it 2 ways. So the first way I said was 9 plus R. No, I'm still on A. Well, close. It would not be 9 as the sum of R. It would be the sum of 9 and R. So you would want to say the sum of 9 and R. And the reason you'd want to say it that way is because you're saying that, hey, you need to add those two together. So the sum of 9 and R would be 9 plus R. All right, now, I'm going to jump to B, and you were absolutely correct. All right, so absolutely correct what we talked about earlier when looking at B. It would be Q. Say it again. What did you say?
I said Q less than P.
Close. If you use less than, it's got to flip, and I'm going to talk about that in a second. What I would say to start this would be Q minus 3. Now, the next one, and we were all over it using less than, but here's what happens. When you use the term less than, you've actually got to flip your numbers. So it would be 3 is less than, 3 less than Q. Because what happens when you use less than is it's really saying the bigger thing goes second, and then you take away whatever was listed first. Okay, so less than is the tricky one. All right. For letter C, 7 times M. Well, the first one I'm going to write is just 7 times M. Okay. Another one, kind of cheating from above, is I could say the product of 7 and M. Because product means the answer once you multiply two things. All right. And then the last one here for D, you could have J divided by 6. Or you could say the quotient of J and 6. Okay. So these are some examples. These are some things to make sure you jot down and you get so that you can use them as we're going through. Again, these are not the only answers, but these are the ones that we feel really strongly about and that were easy to get. Okay? All right. Now, this next one is actually going to have you translate it from word problems. Okay? So you're going to be given stuff right here, and we got to go through and figure it out. So the first example, it says John types 62 words per minute. Write an expression for the number of words he types in M minutes. Okay? Well, the big thing here is you got to pick out the information that you need. Well, what we know is he types how many words per minute? 62 words per minute. That's the big thing to take away. Now, what they're asking us to do, which is what I'm going to highlight in red, is they want to know how many he can type in minutes. So do we know the actual number of minutes? No. But we know how many does he do per minute? 62. We don't want our minutes to be defined. We don't want to say, hey, he does this for 3 minutes. How many words would he get? We want to say, hey, we want to be able to pick out any amount of minutes. So that's why this is important, because instead of saying just 62, we're going to say 62 M. Because whatever number of minutes we have, we can take that and plug that in to figure out the total number. Are y'all with me? All right. So our answer there would be 62M. Okay? Now, let's do one more together, and I'm going to let you do the last one on your own. Okay? It says, Roberto is 4 years older than Emily, who is Y years old. Write an expression for Roberto's age. Okay? Well, what do we know about Roberto? He is 4 years older than Emily, but how old is Emily? Emily is Y years old. Okay? So, We know that whatever Emily is, Roberto is 4 years older. Well, what's our starting point? Well, our starting point would be Emily's age. What is Emily's age? Y. And then to be 4 years older, does that mean we want to multiply by 4? I'm asking y'all. I would say probably not. Do we want to subtract 4? No. To be 4 years older, you probably want to add 4. So your expression here would be y plus 4. Because whatever Emily is, you add 4 to it, and that is Roberto's age. All right. I'm going to pause this, and I'm going to give y'all a minute to work out example 4. Ready, set, go. All right, so looking in here, I want you to check and see what you got as we kind of go through here. Now, this one's slightly different because here they tell you some important information, but then the question they ask you is a little bit different. They tell you that Joey earns $5 for each car that he washes, but then they want to know how many cars he's got to wash to get D dollars, right? Okay. Well, that means that we're actually going to use that and say that D is equal to something here because your total output's going to come from that. Well, we know no matter what, how much money does he get per car? $5, but we don't know how much money he's wanting to make. But we know he gets $5 per car. Do we know how many cars he washes? No. So I'm going to call that C. So to figure out the number of D dollars he earns, D is equal to 5 times C, where C is equal to the number of cars. Okay. All right, so keep moving forward here. All right, now, the next thing that we're going to talk about is what it means to evaluate an expression. All right. To evaluate an expression means simply this, that you are going to substitute in the numbers for certain variables in the expression and simplify it as needed. Okay? So, looking here at example 5, they ask you to evaluate each expression for M, where M is 3, N, where N is 2, and P, where P is 9. So what that means is we want to take each of those values and come down here and plug them in and then solve it mathematically. So for letter A, if we look at this, and I'm going to give each one of these a color. We'll say M is red, N is blue, and we will say P is yellow. Okay? So looking at this, they tell us that A is MN. So that is M times N. Well, what that means is we need to plug in our numbers. Well, we know M is really 3. And we know that N is really 2. Well, if we were to solve that mathematically, 3 times 2 is 6. All right. Then we're going to do the same thing for the next one. You have P minus N. Well, here N is 9 minus N, which is 2. Well, N minus 2 is 7. I heard somebody whisper it. That's awesome. We're making progress. And then the last one is P divided by M. Well, that would be 9 divided by M, which is 3. Well, 9 divided by 3 would be 3. Now, I don't want to confuse you, so I'm just going to talk about why I do this. Anytime I'm plugging in a number for a letter, I like to put it in parentheses to remind myself that I plugged that in. I didn't just make it up. I didn't just get it out of the thin air. I took it from what was given to me. So that's why I put all these in parentheses. Questions? All right. Well, now we're going to get to the point where we get to solve some stuff. Okay? And we're actually going to skip example 7. Okay? We're going to skip example 7 right now, not the fact that you can't do fractions. I just think right now with where we're at mathematically, we just want to spend some more time on some stuff that's going to be of greater importance to us. Okay, so let's look here at example 9. All right, right here they ask you to solve the equation and check your answer. So this kind of ties into some of the practice that we were doing reviewing, right? The goal here is to see your variable, and you want to get your variable by itself. So as you look at this first example, you have c divided by 8 is equal to 7. Okay? Well, the big deal here is you need to undo what's happening to c. Well, c is being divided by 8. How do you undo dividing? What is the opposite operation? Multiply. That is absolutely correct. So to undo dividing by 8, you got to multiply. But if you do it to one side, you've got to do it to the other side. So when you multiply, it cancels out that dividing by 8 and leaves you with just c. 7 times 8 would be 56. You guys got it. All right. Now, example 10 is very similar to that. The main difference here is that you are now taking 0.5, multiplying it by y to equal negative 10. Well, how do you undo multiplying? Yeah, divide. It's just like we did before. It's just the inverse. It's just in opposite directions. Okay? So, if you have a calculator, it would really help you right here. But negative 10 divided by 0.5 actually ends up being negative 20. And that would be your answer. Now, I want to highlight something on these notes that I didn't do here. You could absolutely do this. I'm just not doing it for a time aspect. But they ask you to check your answers. How would you check your answers if we wanted to do that? Does anybody know? What you would do is you would take your answer and plug it in for the letter. So here we got c was equal to 56. You would go 56 divided by 8, and you should get out 7. Over here, you would plug in negative 20 for y, and 0.5 times negative 20 should give you negative 10. That's how you would check it. You plug it back in and solve it. Okay? All right. I want you to take a look at this last one, and I want to see if you can recall it. I'm going to give you a minute to try it before we talk about it. Ready, set, go. So, I set you up here. I wanted to see who could do it, who could figure it out. There's a couple different ways you could do this. Okay? I'm going to show you the way that I initially would do it, and then I'm going to show you a different way you could think about it if you like that better. Okay, I see a fraction. To eliminate a fraction, you multiply it by its reciprocal. Good, I heard it. So the reciprocal of something is simply taking the top and the bottom and flipping it. So if I wanted to get rid of this, I would take 5 over 6 and flip it and make it 6 over 5. And I would multiply those. But if I do it to one side, I've got to do it to the other side. Okay? Once you do the reciprocal, that cancels and leaves you with w is equal to. Now, what I would do here is I would use my calculator. Okay? And I would actually enter it exactly like this. I would go negative 20 in parentheses times in parentheses 6 divided by 5. That's exactly how I'd do it. That's how I'm going to do it right now just to show y'all. So negative 20 times 6 divided by 5 and press enter. And when that happens and it's worked out, you would end up getting w is equal to negative 24. Now, I'm going to show you how you could have worked this out one other way, because some students don't like doing the reciprocals, which is fine. Okay? Now, if you wanted to work this out another way, here's the first thing you've got to do, is you've got to take that w and rewrite this equation where the w is in top of the fraction. So what I mean by that is you would write it as 5W divided by 6 equals negative 20. Okay? Now, when you look at it this way, it's a lot easier to figure out because you could be like, oh, okay, well, I need to get 5W by itself. Well, to do that, I have to undo dividing by 6. Well, to undo dividing by 6, you've got to multiply by 6. So then you would have 5W equals negative 120. And then you could do the things that you've been doing. You could be like, oh, okay, I see now. I need to undo multiplying by 5. Well, you undo multiplying by 5 when you divide by 5. And then you would get W is equal to negative 24. You did it that way? Yeah. That way to me is a lot easier. But if some people, because a lot of people don't like fractions, which is fine. You don't have to like fractions. All right. But I wanted to show you both ways just in case. All right. Now, what I'm going to do to you now is pass out to you your extra practice, your homework. Okay. Does not need to be submitted to Canvas tonight. It is simply practice for you. Okay. But my reminder to you is your test and quizzes are open note. So the more you have done, the better off we'll be. Ready, set.